Hi, this is David, continuing with an introduction to the Texas Instruments BA2 Plus calculator as we would apply it to typical questions in financial certification exams like the FRM and CFA. In the previous video, we looked at this third row of the calculator and we saw that we could solve for the price of a bond by computing its present value. These keystrokes are labeled in generic time value of money terms, which map to specifically bond terminology in the bond asset class. So this time we're going to look at another common question which would ask us to solve for the yield of a bond, and we'll see that that's going to map here to this interest rate key in generic terms. Now my question here has yield and then parenthetically YTM, and that's because there are several different definitions of bond yield. We typically want to be specific about what kind of yield we're referring to. However, by convention, yield by itself connotes or implies yield to maturity. So it's specifically what we're looking at here is the yield to maturity. After we show the calculation, I'll show you a brief interpretation of what we mean by yield to maturity. But for now, let's look at the word problem. What is the yield of a $100 face value bond with 5 years to maturity that pays a semi-annual coupon of 4% and has a current price of $92? So there were two key tips I tried to share in the previous video, and the first one was to immediately establish the discount or compound frequency. Now technically that's the periodicity, but what we mean is, what are we discounting this at? Annually, semi-annually? How many periods per year? Well, this bond has a coupon rate of 4% per annum. Now the per annum isn't explicitly stated, but the coupon of 4% per annum, this 4% really always should be in per annum terms. Otherwise it gets confusing. The coupon rate is 4% per annum, but how often is the coupon paid? It's paid semi-annually. So that is the glaring hint. It's all we need to know that our discount frequency is semi-annually or twice per year. So we want to be mindful of that when we get to the answer. We're discounting it twice per year because the coupon pays twice per year. If the coupon paid annually, then our discounting would be annually. And the second tip was simply that we've got 5 keystrokes, and for any of these generic vanilla basic problems, it's always going to be give the calculator 4 of the inputs and ask for the 5th output. And this is the case here. In the previous video, we gave it the 4 aside from present value and solved for that. This time, the question's asking us for a yield, and so we know we're going to be solving for or asking the calculator to compute what it calls the interest rate, but for us in the bond asset class is the yield to maturity. So we can do that by inputting the 4 that we're given, the 4 inputs, and asking the calculator to solve for the 5th that we don't have. So if the first, the way that I like to work, this is just stylistically, I like to go across the row just to make sure I'm hitting all my bases. And so N is the first keystroke here, and we've got a 5-year bond. Notice I put that in. And then I want to be mindful, wait, what's my compound or discount frequency? I'm doing this semi-annually twice per year. So I need to multiply 5 years times twice per year because I have 10 periods in 10 semi-annual periods in 5 years. That's my N. My next keystroke is what I'm solving for. I skip it. The next one is present value or the price of a bond. Well, we're given that. It's $92. And now what I like to do is just imagine I'm paying for the bond, which is a cash outflow. So I make that the negative. And I give it the PV. And then the next keystroke is the payment. Now that's generically the time value of money. Recall that corresponds to the bond coupon. What is the cash flow each 6-month period? Well, our coupon rate is 4% per annum. And that is 4% of what? Of the price? No, of the face value always. So that's 4% per annum, but it's paying every 6 months, so we divide by 2. And so the coupon should be $2 every 6-month period. Now I leave that to be a positive because if I've paid for the bond, that $2 is coming back to me as positive cash inflow. Now I've only got one more keystroke I need. Generically, the future value, which in the bond asset class is the face value, could also be the par value, could also sometimes see the principal. I like face because face value has the same FV an acronym as future value. So we put the 100 in, hit future value, and you'll notice I've worked my way across. I've given the calculator the 1, 2, 3, 4 of the 5 inputs. Now it just needs to solve for me the one unknown. So to solve, we come back and say compute the one we don't have, the interest rate, which for us is the yield to maturity. Now what answer did I get? I got the yield based on a 6-month period. And remember, we always want to take our inputs as per annum, and also we want to express our answers in per annum terms. In this case, we would call that bond equivalent basis. So we want to remember at the end, this is a common mistake that leads to an incorrect answer, but where we forget our period is 6 months, and we need to, at the end, multiply by 2, convert that into a per annum or bond equivalent basis, and you'll notice I get 5.87. That is, based on this, the yield, or specifically the yield to maturity of this bond. And you'll notice here, Excel, I got the same thing with the rate function, and then internally in the rate function, I handled this conversion to a semi-annual discount basis or period. Okay, so 5.87. Yeah, if you work with bonds a little bit, you'll notice that one of the first things we do is check that. We saw that the price is lower than the face or par value of the bond, and that means the yield should be higher than the coupon, which it is. So directionally, it looks good to us. Why is that? Well, that's because if you're getting a 4% coupon, that's your income in the meantime, but you're also getting appreciation. You pay $92 but get $100 back, so you're getting some capital appreciation as additional yield here. Okay, so if we just go quickly to the interpretation, if I take that yield of 5.8%, we got that as the answer because it is really an internal rate of return. Here is if you go ahead and purchase this bond, here is your cash flow stream. You're going to get $2 coupon every 6 months. And at the end of 5 years, you're going to get a final $2 coupon and the return of the par value of 100. And the yield is the number such that if we use that to discount, here's the discounting function, discounting and based on the term. If we discount each of these future value cash flows, here they are in present value terms. So here's the present value equivalent of this future value stream. And if we sum that, we get the price of the bond that we observe. So the yield is what sets the present sum of the present value of the cash flow streams equal to the current observed price. And also, it's going to be the realized yield of the bond if this is an important assumption, a dubious assumption, if we're able to also reinvest these coupon cash flows in the meantime at the same yield. So it will not necessarily be the realized yield. That's only conditional on a reinvestment equal to the yield. But it's the internal rate of return that produces a sum of present value of the cash flows equal to the current observed market price of the bond. So that's it. This is David. Thanks very much.